Let me just explain out loud what I have to do. Look at that. Design reality. Design. So this thing has a like position, attitude, and space. Since it's a car, it's like two-dimensional. There's no height difference, hopefully, like it doesn't fall. And then you've got several things. Like there's the computer itself, but you've got distance sensor, camera, then you've got the servos. You have to control all those and the light, but that's just on off. Oh, and then you've got the IMU. That's not it. It's that one. And on the left here, got I've interfaced with everything. You know, like auto control servo. There's like WebSocket code because I want that talks to the Wi-Fi buggy, but also I'll have a web interface, and the navigation unit will like spit out data, like its telemetry and all that. Then I've got the WebSocket, which there's a problem with this one, so I've got like a wake up command that runs on boot. So, yeah. Let's see, servo, all the sensors, I interface with them. So now I have a class-based thing now, nav unit, and I have to put everything in there, and I'll maintain the state, because as it moves, it has like an expected, you know, like if you say move 10 inches, it expects that it moved 10 inches, but the IMU will also check against it. And the positioning is based on the IMU. There are no like rotary encoders or anything. I'm starting to form the idea of how this thing's gonna work. I have to maintain state, so there'll be like properties, like position in 3D, or actually it'll be 2D space because it's an RC car, and then track the servo positions. I always know where those are. Then make methods that access the sensors and the IMU, and then build the IMU based leveling and the panning. I still need a way to center. That's still something I have to figure out. I'm gonna try and do the that's my cat. He has a weird breathing condition. Like a red wire that sticks out, and then the camera like looks down, centers itself, and then that's the center. So yeah, it's trying to come up with names too. UwU Navu. Just gonna go over the code real quick that I have. Right now, navigation is not there. I'm still like wrapping up all the interfacing. I'm just trying to show how I decided to group the code. This is here. I was just commenting out all these prints because when you call the VL, the time of flight sensor, ranging sensor, it dumps a bunch of crap like this, you know, like a bunch of these. So I had to find the ones that were dumping and turn them off, and then run the make command again on here. And then so yeah, this is the entry script. Let me just close this. It's right here. This is the current code structure, which might change later. Yeah, here. And then the other things are here. When this thing boots, there's a shell script that calls Python. It runs this nav unit, and when that runs, it starts up a bunch of things. One of the things is like it pulls the LED off, centers the servos, and then these are gonna work too. Not the photo one, that's just there to remember. But the IMU wake one is a process that has to run. But there's problems with the library imports right now. I'm doing this nasty like syspath insert or append. But yeah, so startup, then this is how you address things, and then this right here that you're seeing is this call here, which happens during boot. But I can trigger it manually, and I'll film this real quick in sync. Let me see. Oh god, I only have 2 hands. Let me see. How do I do this? Okay, we got this wipes thing. Oh crap, I don't have a memory card. What? Where did it go? Okay, so this box 5 inches away. Box is 5 inches away. I'll just run this command. Let's see which one's better. They're both bad. 6.5. Actually, that's right, because it's 7 inches. So 6.5, 6.24. That would be like here to here. It's not exact actually here. Let's try it again. Oh, there's this thing too, I forgot. Let's try here. 5. Okay, now let's see how accurate it is. 702, that's pretty good. 624 LiDAR. The LiDAR is better, like farther away. That's why they're both on there. The beam is very small, like 3.6 degrees. The other one is huge. It's like 725. Yeah, so then continuing on this code structure, I'm not like that great at object oriented, so it just made sense for organizing things. As far as like hierarchy and sub methods or whatever. So you go to sensors, there's this class, and then it has subclasses for each thing, like the IMU, LiDAR. There's the time of flight sensor that's being used here. Same for the LiDAR. Somewhere. Well, it's right here, just printed. But yeah, so I'll finish this, and then at this point I should be able to start dealing with like navigation and mapping. I still have to come up with a loopback thing for the IMU where it'll use that to level, but also if it's moving, it'll sample that to like double check that it moved the expected amount. And I have to set the servos, make sure like, you know, you tell it to turn so it probes something at a certain angle that's correct. That'll be interesting to get that right. That was interesting. This was broken, but I guess not. I just commented back in the IMU wake function. You can see the delay. It does like a loop until it gets the IMU up. And then now I can just run the sampling. Come on. Wait. What are you doing? Oh, come on. Focus on that. There. Run the sampling. And there's the IMU data. Well, you can't see it, but if you watch the Z gravity value, 1 is level, and then that one is nothing, like orthogonal. Cool.